Hey everybody, this is Larry. This is day 20 of Advent of Code. I'm here back in New York, so I'm just setting up, doing it live. So yeah, there's about 33 seconds to go. You can't really see on the screen, it's day 20. Yeah, so I don't really have much to say. This is live. The explanation is near the end if you want to fast forward to that part. Yeah. All right, good luck everybody. I hope I had good luck too, I guess. But let me make sure everything's set up. I think I do. 10 seconds to go. 10, 9, 8. Let's go. A lot of clicking. I don't even know if that's the example, but okay. Let's actually read it. Destination, okay. Flip-flop manager, okay. Conjunction module. Okay, human one. Okay. Those flip-flop. Okay, so okay, I guess that makes sense. Okay. I don't know if I copied the right one, but okay, so this is the actual example that they want to use. Okay, and now what are we doing? We have to pause it, but that's fine. Or inputs. And I do not know what this means. This is so much reading. Okay, well. I don't know the sequence of all these things because it does multiple things, right? So A to B. It is such a annoyingly reading one. I don't think that's my strength, so maybe we're not leading today. Center low, right? So center low. Oh, so this high doesn't do anything, that's why. Okay. I see. I see. I see. Okay. Well. It's not our strip. They always tell me. What? No. It's not our strip. It is our strip, right? Is it? That's weird. Oh well, okay. Okay, and then now press 1,000 times. Okay, fine. And then now record the low and the low and high sign. Okay, that's what we pressed, and now we press the broadcaster. We send oh, I see. I actually misread this part. Low post to broadcaster. Just say low 0 then. Okay. Okay, and then now look up our name, right? So then now for module name we the name has the thing on it. Okay, fine. Oh jeez. This won't even work. It should be let me see, go to this. Did I just say 0? we'll have to do. So, okay, so if is equal to 0, then what do we do? 9 minutes. I'm just still reading this far. Okay, so then it's sensor. Okay, so we need a flip-flop thing. Flip. And flip of name is equal to 0 because they're initially off. Conjunction view. Okay, so for man, I have to remember these conventions. So and yeah, okay, so for actually this is wrong. It's 0 for off, 1 for on. Okay. Okay, so then now it tries to send a pulse. That's fine. I think I can. Yeah, whatever, 2 doesn't really matter. Okay, so now. Right, current type is equal to type of name. Okay, now it flip flop. Okay. Okay. If CT is equal to 1. Wait, what? Oh yeah, if type is equal to 0, then it's a flip flop. Maybe I should break this out, but maybe that's fine. Okay, so okay, then now if pulse is equal to 1, then we return, we do nothing. Otherwise, it flips between on and off. Starts at off, so then it turns on. So flip of name is equal to enough. Yeah. Why do I use these conventions? If it was off, it turns on and sends a high pulse. Okay. So then now it sends a high pulse. So if it was off, if this is 0, we send a 1. Okay, so actually I guess this kind of it's kind of worked this way out actually. But I think that's right. I made it more difficult to debug though, to be honest. Okay, right. The most recent post we okay, so remembers a low post. When a post is received, the country updates memory. Okay. What does for all input means for that input? Received for each of its connected modules. This isn't quite right, or at least not sufficiently. I have to do something like a sender. I guess it gives me a chance to do everything, but okay. And then now, so con is actually should be a okay, so then now con of name kind of name, right? So if all of con dot values if this is equal to 1, then it is, if this is all high, we send low, so low is equal to this is true, right? If low, then we send if low, then we send a high, no, we send a low because they're all high, so we send a 0 to all inputs, and then just remember her name. I guess this could have been into this, and then now if this is true, then it sends then 1 minus low. This is bad convention, by the way, so I don't know if you should do this at home. Okay, right. Okay, and then now if post is 0 0, low else hide. I know I have to do it non-local. Okay, am I finished? I don't know. Too many ways to unpack. Why? Podcast to A, what? Already debugging? Oh, the space here. Oh no. I guess maybe I forgot about that. I don't know how these work. Actually, I guess that did work. Okay, let's try that then. I didn't think that would work, actually, honestly. Okay. Press the low 1,000 times and it does nothing. Well, so this code doesn't work, which is not great. But we could play around. Okay, we pressed the button 1,000 times. Okay, let's just press it once for debugging. I mean, it doesn't do anything. Okay, so then now broadcaster. Oh, because it doesn't. Okay, yeah. Whoops, I forgot to write it for broadcaster. Broadcaster just sends a load to everybody, right? Is that the? Oh, it just sends all the same posts to everybody. That's actually easy to write in our framework. QLA 62 type of A. Do I not send order type correctly? Oh no, did I not huh? Is this not right? I literally have a thing that strips it. Oh, Larry. Okay. Oh, is it an output? What is output to? I guess output does nothing. I hope. If it does something, then key error con. Why? Did I just delete this? There's a con. Oh, there's a space. Oh. I thought I stripped. Okay, 1 and 3. That's not quite right. Maybe. I don't know. I don't know if that's true. Let's do it 1,000 times. Just to be sure. Nope. Well, I mean, that's something. Actually, we have some. We have debugging already, kind of. But that's done only once. Alright. So broadcaster sends low, right? Broadcaster sends A, low. A sends a high to inverter, and A sends a high to high. Huh, maybe I'm processing it incorrect in the incorrect order. Okay, so I did this incorrectly, kind of. The post is sent to ABC, and then module A processes posts, and send more posts have to be handled first. Okay, I see. That's not that bad. It's not that great, but it's not that bad. Okay. Okay, man. This is actually not that hard. It's just a lot of reading, but that's not great for us. I mean, okay. Fine. I actually misread this. I actually was thinking about this during the thing, but I misread it. Still wrong though. Why? Tell me what? Same. Oh. Should I go print this? I think it's still just this. Okay. Oh, okay. A sends. Broadcaster sends low to A, and then A sends high. Why? Oh no, I'm reading it wrong. Or maybe I am actually. turn on, sensor low to output. However, okay, so flip flop gets a low. It flips. If it was off, it turns on and sensor high. Right? So it turns off and sensor high, right? I don't get it. Broadcaster sensor low. Turns on and sensor high. Oh yeah, actually that matches what I think. Invert gets a low. B sensor high. Oh, okay. I'm missing the converter sending stuff. B for the B. So inverter sends a low to B. That's good. But then the high doesn't. The converter doesn't do anything on high. Okay. Or maybe I just returned. I don't know. Okay, so I just returned because converter press press a low to output for some reason. Converter. I don't know if it's called converter conjunction. Teach input. I see. What is going to all inputs? Okay, so conjunction needs to. Okay, I need to set this up a little bit more. So with the conjunction, then we have to look. Oh no. Okay. Okay, fine. I have to double parse it. Okay, we need this, or this, or this, or this. Basically, if we want to look at the parents to set up the inputs. Okay, so then here for X in output, that's split. If type of X is a conjunction, then con of X of name is equal to 0. So we set up the default thing. What? Why? Everything should be set up. 961. No, I mean this should be set up from before, right? It is there. Huh? No, it's the space thing, Larry. Output, okay, fine. I forgot about output. Oh, because output doesn't appear as a name. Okay, fine, I just hack it. Okay, I mean it's still wrong, but maybe it's a slightly better wrong. I don't know. Or maybe I have to do it 1,000 times. I don't know if like 0 to 1,000, that doesn't help. Let's see, it does something different, but let's see. So much debugging. Definitely not leaderboarding on this one. I can't sensor high to output. Okay, inverter sends thing to B, can't sensor thing to output, and then we're done for some reason. Why? B sensor. Something sensor low to. Okay. Oh, inward sensor low, but sensor high. Why? Okay, so A is equal to 0, that's fine. A sensor high though, so this is not fine maybe. I don't remember anything, do I? Oh, why do I not do it? How did I forget this? Nope. I guess I just forgot this. Whoops. Alright, 1, 3. Is that better? I don't know. Let's see for 1000 because I think it changes a little bit. Otherwise, it would make sense. Nope. Debugging is the worst. Oh well. Okay, so A sensor high to inverter, A sensor high to con, in sensor low to B. Okay, that's good. Con sends a high to output, B sends a high to output, and sensor low. Right? Okay, so I mean that looks like that's right. Right? Am I miscounting stuff? Or they only count the output? No. Okay. But also, my counting is just wrong. Because I have this silly thing about output early. I am not a smart boy today. Alright, it's still wrong though. Why am I showing so low? Tell me why. Alright, let's do 2. The second one, the button sensor low, okay, broadcast sensor low, and A sensor low to both. Inverter sensor high to B. Dun, dun, dun. Oh, this is pulse. Why would I write 1? Did 1 minus pulse? Did I mess it up? I mean, this counting isn't even right. Why was my counting so off? Why is my counting so off? All you have to do is just increment and stuff. Huh? I don't get it. Why are we documenting stuff? How does this happen? Man, I must be missing somewhere. How? feel like I'm almost done, but then I don't know how like we document this stuff. Oh, you idiot. Reuse variable names, shadowing, whatever. That part of Python I actually hate, the shadowing. Okay. Okay. Oh no. It works for the input but not the whatever. Why? Hey, what? Line 62. What? Why? Why is RX not in here? RX? Did I have the wrong input? Or what? No, I still have it. Did I misunderstood the problem? Untyped thing. Okay. I guess it has untyped things. I didn't know that. Okay. I have to hack this. What line? 94. I think I didn't know about untyping stuff. Lookup name. If name and lookup. Alright, we're putting way too much, but that's fine for now. So slow. 5. I mean, better than nothing, I guess. Oh, there's. I'm talking when a single load post is sent to RX. We said. Oh, okay. I did. I'm not gonna copy and paste this. This is too much. So I'm just gonna edit in live. Actually, now Larry, don't be lazy. You're already not hitting the leaderboard, so it's fine. It needed a better process for this part, though. Also need a debug function instead of all these print things. Okay, so then now okay, and then key is not defined. Did I not copy paste everything? I didn't copy. Huh, how did I? Did I mess up on my copy and paste? I like 8. Something got deleted. I don't know what happened. Let's see, hopefully. Oh no. I think something happened during copy and paste. I just deleted it by accident. Oh no. Hey. Ha 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 ha. Damn it, Gmax. Alright, well. I don't even know how to start. I mean, I have my screen recording, I guess. Let me see if I can use that. How dumb are you, Larry? Hey. So I'm cheating by looking at my old code. How did this happen? Okay. I guess that's one thing about oh. No conventions anymore. Oh man, how did this happen? I guess I could review the tape, but oh well. I mean, I'm glad that if it were to happen, it happened in a problem where I am not on the leaderboard, because this would have been, you know, way more sadder if not. Wow, that is a lot of code. What happened? I don't even have 2 monitors to make this faster. This is such an easy fix for a type thing too, which is the sad part. There are a lot of sad parts actually, but that's one of the sad parts. Okay, and then I do a full line, do the same thing really, but then I do something different, I guess. I do something like I didn't write this like this in the other one, but okay. But what is the other change that I fix? Or X stuff. So basically, I also hacked in. T and T of X is equal to, just for funds. Is that good? I think that's all. But what a dummy. I mean, this is only for part 1. I just want to see if part 1 works. This is in part 2. Yeah, part 2. Okay, part 1. Part 1 works. Okay, so then now we copy this one. The consolation prize would have been just like a fast part 2, but didn't even do that. Okay. Okay, so maybe it doesn't run, I don't know. Single load post is sent RX. Oh, I even got that wrong actually, I think. RX post is equal to 0. But they don't do it for the example, do they? Maybe the example doesn't do it because yeah. Does it actually take forever, or does it? Just want to see if they actually send stuff here. Okay, so we actually send stuff here. KC, okay. So that's good that we actually process, but KC is a thing, so then KC or has to or high or something. At this point, I'm going to cheat and look at the eDeboard just to see if how many people got both. No, a lot of people got both, but it took 23 minutes, so it's not a for loop. I thought that would be a for loop, to be honest. And if the fastest people took, I don't know, 8 minutes, then it's probably not that. Well, they leave it running for 8 minutes, I guess. Which I guess now I'm gonna do. Okay, and then while I do that, while this is running, I guess I can take a look, think. So after each press, so KC is the thing that matters, right? So maybe print KC. Was it con KC? Oh, whoops. So when we send a high, oh, it sends a low. What is the country? If it remembers a high, it sends a low. But we don't even press this. Presses doesn't seem like it does anything. They're just sending lows, so all the other stuff has to be high. Am I doing something wrong? I mean, I don't mind waiting forever, but I don't think this is, I think something's a little bit off. All posts is to be fully handled. Something is wrong, isn't it? What could be wrong? I mean, it only gets sent zeros, so that doesn't. Do the states differ? I mean, the conjunction states do change. So this is something harder. It's not just okay. I wish I did part 1 faster, then I could actually have fun with this one. But so let's do some detective work, shall we? So we have these things. all they do is send zeros. But the state of stuff do change, so wait. You know, like was it KB? KB changes stuff. So KB is a thing, so KB has to go. This is very hard to read though. We don't need the KC part. And I do want to put a pretty printed somehow, but see if I can eyeball something real quick. Is this cyclic? I don't think so, because if it is, then it would just never complete. Or at least not at the pace that we are. A lot of conjunction things. MF. I have to figure out a better way of doing this though. Well, I guess it doesn't really have to be default text. I kind of did it default text because yeah. Slightly prettier. KC still after 16,000 clicks and maybe even more still has not done anything. Alright, I just put it here so I could have it in the background and kind of see maybe as it goes a little bit further out. But pH is 1, which is good. So it seems like it probably is eventually all these close to this flip-flops. VN is good, but how come VN doesn't send? What does VN do? VN is high. Did I mess something up? It remembers high, so why does VN not send? Why does VN not send 1 to KF? KC. I do have to put this on. Oops. Oops. Okay, VN is sending 0, even though this is a 1. Oh no, if it remembers all high, so it does remember all high, so we have to, so this has to turn to 0. Okay, so I think I'm just misunderstood some of this, but okay. So this has to turn to 0, this turns to 0. But isn't this 0? What? Okay, if all remembers high, it sends a low. So this sends a high, this sends a high to here, and because it sends all high, it remembers a low. Okay. Still putting. Okay. KB alternates on the TN. BX is the only thing that matters, is it? I need like a string difference. Yeah, I mean after a million presses it's not doing anything, but alright, let's figure it out, right? So okay, how do I do deep copy again? That crappy afraid that I did it of JSON. Something like this. Okay, but then now we want to what do we want to do? We want to look at the delta, right? That's why we set it up. Okay. And then basically, what are you doing there? Key to the previous new thing. All right. See if we find any funky things. I hope that doesn't do anything. Oh, like that file I don't have. Okay. Let's see. Right. So it flips from 1 to 0, okay, and then 0 to 1, 1 to 0. So this thing, so what I'm trying to do is just trying to see if there's like a counter somewhere, or it's trying to do a counter somewhere and then try to figure out the math that way. I mean, it's still not working up to 3 million, so. Okay, so MF, NR, and flips on every one. What would I want them to be? What happens? This also flips every other one. There are a couple that does flip every other thing. How can I use that? This flips every other one. So there's probably some cycle of like a lot of these things, and then we have to figure out, is it always a cycle? Like PHNH, that only appears once. KBTN appears every time, right? KBHH appears every 4 times. It has to be at least 4. Or like multiples of 4. And then this thing is every 4 as well. Is there a cycle thing though? And like, for example, I don't know if that just like happens once in the beginning kind of thing. Because some of these events just don't happen then, right? And we're only putting out stuff that happens enough. Like this one is every 16. So it's going to be multiples of 2. Okay, so then now, okay, I see. Let's see, right? How do I want to write it? So this is comparing every 2. This makes sense that DHDJ is different. Am I doing this right? 1, 2, 2. So this compares with 0s. That means that things are alternating. Okay. Yeah. So then now this means that this thing is every 2. Right? No, this means that this thing is every, yeah, at least every 2. That means that this is going to be, okay, so then now, I'm trying to think whether I can do repeat multiply in a good way. Or like that kind of idea. Right? After 2 presses, these things change, and every 2 press, every 2 presses, right? No change of 2, so that means that this is, what does that mean? That means that this is every 4. I don't know if I'm quite understanding what I'm seeing anyway. I guess now this is every 4. So, oh, okay. Let's look at 8, I guess. I guess we don't need to. All right, so every 4 we have a couple of things that change, and that means that, how can I figure out what that means though? That means that this is every 8. Is that true? It is, but what can that do for us? I mean, I think, like, you know, it still takes a while to simulate. So nothing changes except for these. But then what does that mean for me? Okay, well, it's gonna be multiples of 2s. Can I simulate more than one at a time is what I'm trying to figure out. Because there is something, I don't know how to do this new part. So cycles is only every powers of 2, but how do you... Okay, so for example, if every 4 of these changes, how do we figure out which one changes every 8? Well, I guess this one, but what does that mean? We still have to simulate all the ones in between to get it, right? How do I do I simulate twice? Like, what happens right after the 9th? Okay, let's try that real quick. So 8 and 9 is going to be the same. I mean, some states change, for sure. So then maybe we could do it manually? Does that... Because nothing changes until... Okay, fine. So then... Every 8... Okay. So for example, if we change this to 8... I think I guess I get the idea, but it's still really clunky. Like, this is every 8. Is this every 16? I guess so. But how do you... Okay, so you find the starting point. But you still have to simulate half of it to get to the next half, right? Or at least the way that I'm doing it. Because you still have to figure out the inputs. Without drawing it anyway, drawing it out. which maybe we have to do. I don't know. How many rows do we have? And knowing that this changes every 8, is that helpful? I don't know. And the others changes every 16, I guess. Or 4, I don't know. Yeah, so these changes every 16. Because it just gives us a starting point from the 16, right? So now you have to figure out how to do the 32. But you only go to 32 from 16 to 32, so that's not very helpful. Did I cancel this? Oh, it's keyboard interrupt, that's not great. But I mean, it's not doing after 8 million, is why that'd be funny if it's just like 2 more than that, but no, I don't think so. I mean, I think we probably went over that before anyway, but so every 32 we get this, but then how does that factor in? Like, some other, okay, so what happens during a state change? Like, okay, let's actually print out all the other things in the middle for a sec. Just comparing per 8. So 9, 10, so nothing changes. Nothing changes from 8 to 16. I mean, these are because this changed here, right? Nothing changes with respect to 8 ago. What does that mean for me? When does the actual change happen to the... So is one before... So if it... So it changes for a thing that changes every 8 steps. The change happens on the 15th step. But none of the state. So then that means that we just combine the 7 and the 8. Right? The state of the 7 and with this change. So then now we're saying we add the change. And we know what changes in one step. So it becomes like I mean, you could do a binary search on it if you're able to compose it for whatever. And you can compose it by taking the number of one-step changes plus the number of two-step changes. Because then now, okay, and you just run it for one step. Okay, so to get the next number. Okay, so then you want, this is hard. Okay, but I get it. Okay. Okay, how do I do it? Okay, so then now, how do I code it? Okay, so then now, okay, so I need a reset thing too, just to make myself a little bit cleaner. Reset, that's the only thing that matters is con, so, okay. Okay, and then now, so we press once. Okay, we reset. Apply. Okay, well, let's just say we reset, we press once, and then we calc delta maybe. Just with empty, I guess. We could just do it this way. Okay, fine. C2. Oh, for original, maybe? Okay. Okay, and then now, so one step is equal to this. Okay, let's do it this way. And then now this returns. So the new one, right? Okay, and then now, so that's for one. And now we want to start with two, which is one shifted by one anyway. So basically you take the deltas are not actually quite like this, is it? Delta is equal to delta. We can actually put it as a list, and then delta dot append kt2, and those are just like we swap, right? Okay, and then now and then now we want to apply delta. Okay, we want to reset. So we sum up all the other ones. right, for j in range of I, and then we apply delta of j, maybe it doesn't really matter, or 1 to the j, maybe that's a little bit easier. And then after that we press once, and then now I guess calc delta is just the number, the difference, but I think that should be maybe right. Oh man, okay. Right, so then now for key 2 in delta sub k or sub x, con of k2 is equal to not, or 1 minus this, I guess. Okay, right. Let's see if that does anything. I think after this there are a couple of ways to do it, but like you could but I'm just going to do binary search probably. Alright, let's see if this crashes real quick. Okay, it does. Key 2. How did this work? I think I just accidentally print a tuple. Okay. Wait, what am I looking at? Oh, whoops. I meant that keys. Okay, and then, let's see. I should have kept the other code actually. I guess this code, which is fine. I guess I did keep it actually, so that's fine. Let's see, deltas. Okay, well it doesn't do anything, so that's not good. Oh, I forgot to process. Okay, fine. Oh. Always worried I accidentally deleted a chunk like before. So 1, we have a bunch of stuff. 2, you have a bunch of stuff. Are these accurate to what we said before? So okay, we do 1. It's going to be change 2. I want to sanity check this. Like this can be 1 and 2 at the same time, right? Well, it copies against the original. No. It's the original one, no? No, because I think the initial kickoff is a little bit weird. I think that's why for me. So initial kickoff has a lot of random stuff that's... It shouldn't change on 1, 2, and 4. Right, because that doesn't make sense. Oh, because the 1 assumes that all these changes every 1, but maybe not. Or maybe that some of these just... Some of these just... okay, so... I think I want to press it twice. Maybe pressing it once is a little bit weird. Yeah, that's what I was worried about, but Because in theory, if this shows up here for 2, then it should not show up for 4, because it does it twice and it should toggle, but clearly this is not really right. In fact, it just keeps growing. Oh, it doesn't even grow. It does some like weird stuff. I mean, also in theory, I didn't take out my assert force yet, so I don't know how to do part 2, I guess. Maybe some of my assumptions were wrong. At least the way I'm coding is weird, maybe. So the cycle is not that it does 2, it's that it changes every 2. That means that every 4 is going to be the same. Does that give me anything? That's why some of these are definitely wrong. The one thing is a little bit weird, for sure. Like, this is definitely new. Why are all these here? Because you're comparing to 0 and it includes the ones from ones. Delta, deltas. Oh, wait, no. It's only the deltas, but what we want is what do we want? We want to calculate the delta that is from doing 2. No. So to get a 4 difference. The way this is done is really wrong. Okay, so to get to 2. is it true that all these are different after 2? Oh, because I see. They're different. Because precisely. Because the ones are not taught. Because they're not all ones. Okay. Also, we apply these 2 together, then that's not gonna work because you want this and then apply twice. You skip ahead another one, but so you want 2 to be the delta from 1. Is that true? No. Okay, so 1 and then not 2, but that. No. Animal. Caps lock on. No, it's not a conjunction thing. Okay, so I'm not storing I'm storing the deltas of not the cycle length. But no, but you can't store the cycle length of things necessarily. Okay, we can figure out the cycle length. So we press 1. Maybe we could figure out a cycle length a different way. Same idea. So we press it twice. Well, there's no cycle length with 1, but we press it twice and it changed twice, then it should be good. Okay, maybe. I'm just going. Okay, so we press, we process, and then delta. No, current delta is equal to calc delta with the original one. But then if you press it again, process it again, delta is equal to calc delta of O again. Then now anything that's in delta 1 but not in delta 2 means that it flips on 1, right? So changes. Names are hard. Delta, so changes is equal to so things that are in delta 1 not in Delta 2. Actually, I can just write set. So that means that these things flip every one. Okay. Okay, I think we could work on that. And instead of the entire thing, especially with initial kicking off things. Okay, so then now okay, I don't know if the move x, right? If x is equal to 1, we process, we return. Otherwise, then now so we have changes of right? Otherwise, we get the changes. Pi delta on x. I guess this is now changes. And it should work because it's a set anyway. Okay, so then now we don't use deltas actually. Okay, fine. But we just renamed things in a way. Okay, so we can say we move 1. Okay, so oops. I'm trying to figure out a clean way to do it. Okay, fine. Okay, and changes of 1. So this is change of 1. Okay, and then now changes of 1 to the I is equal to. Okay, so we reset. We don't need to do this. It's fine. So then now this is move of 1. So then now here we want to move of I. Okay, so to get a cycle length of 2, well, we move 2 steps. How do we move 2 steps? You move. How do you move 4 steps? 4 steps, you move 2 steps, and then you simulate 1 more. Or two, and then you simulate 1. Do the 1, and then you simulate 1 more. Okay, so you move 2 steps. You move. Okay, I see. So then now for J in range of I, you move this many steps, and then you move 1 more, and you do it again. And then now, let's see what is the difference. Okay, I don't know if this is right, but maybe it's a little bit more promising. All right, well, apparently no changes on any of these, so that's not really real. Why is that? So these should be the things that so after two, okay, let's actually make sure. Let's try it. Okay. Move one is the same as move one. Okay. What did I want to say exactly? Okay, processing it twice, or we don't apply delta on one, that's why. So that's why it's a little bit awkward. Even here we hard-coded this cheating thing. Let's remove this real quick. Delta 1, and then remove 1. So definitely we're missing some things in calculation. We have to kick off the initial things. That is the difference, because then we're applying things with our, so there's like things that you just a cycle of 0, I guess, right? I think that's what I'm missing. So changes of 0 is equal to things that changed. What is delta again? Delta is after one move. Do I even have the delta right? After one move, okay, you have a set of stuff and it's, okay, no, it's gone. So then now, the things that are still there probably won't change ever. So basically a set of delta 2. Oh, it's the intersection, I guess. So then now maybe apply delta 0. Nope, still not quite right. Does this do anything? Nope. Actually, it's a little bit weird that apply 1 and then apply move 1, it actually gives me more stuff, because I actually thought I would be missing some stuff. Are these at least consistent? Easier to eyeball. There is some junk. So move one. The pi 0 didn't do anything. Oh, because a pi 0 isn't a real 0. No, Well, I mean, it should be fine. Maybe. Oh, this is divisive. It just means these things are never just flipped once and then never changed again. Okay, that's actually looks right. I mean, I don't know if it looks right, but it looks sanitary. Okay. So this should be right, because this is the simulation of 2. Does order of operation matter? Kind of does, which is actually not what it should be doing. Supply total. Okay, so it applies the zeros correctly, presumably. So that's a 0 set. And then applies to 1 set. Let's just move 1 step. Alright, Larry. Are these the same? It's okay. So for 1 step, this is actually pretty good. Okay, fine. And then now the problem is moving 1 more step. Are there... Oh, I didn't consider the on-off-ness. So I just have to do the on-off-ness as well. Okay. I am a dumb boy today. Okay. I mean, the idea is, I think we're close, but I for some reason I didn't remember that the on-off. Is that true, flip-flop? I guess we just pointed out. Let's see. After reset, and we only reset this, we don't reset the flip. Is this reset it a bit better? Just curious. Okay. Oh, it was carrying over extra things from before. Whoopsie daisies. Wait, that's not true. Well, maybe it is. I don't even know anymore. Okay, so it still has some stuff. Okay, let's see. Let's make sure that this is correct first. Okay, so that's good. Good. Not so good. Why is that? Move 1, we press and process. So now a lot of these are gone, but oh, but we don't do the states. That's why. Okay, that's fine. We could fix that, even if it's been a while. Okay, so this, let's just say this is con. T's equal to con. Else. Flip. Okay, fine. Let's just do it the other way. What I call it? Changes, and then changes, F changes, because F them. I got nothing, sorry friends. Alright, calculate delta. No, actually we do one this way. Yeah, okay, fine, we'll do it this way. Okay, for key and flip the keys. Deep copy. Deep copy of what? Oh, con. Okay, fine. Okay, then the calculate. Now, yeah, whatever. What am I doing? Okay, maybe this is slightly better. Okay, yeah, so some flips changed. Did we fix it? This is the thing, right? Alright, so that means it works for, oh no, yeah, so it works both ways now. Okay, now what do we do? Changes to right? So 2, we have all these flip changes and this thing. Okay. Is that true? Okay, let's audit this for a second. Why did I print that? Oh, these are doing half the moves. So if we say here, we want to do all the moves. Okay. How do we calculate that? Right. Does this even look remotely similar? I haven't printing out changes or something. What I meant is the one we just did. No, we want is delta 2, so then we go to apples to apples. It's not right with the brute force. No, because this is this times 2. Maybe. Alright, so now we got it. This looks like it passed the smell test. Okay. I guess we could always do it. Okay. So then now, I don't know. Does it ever assert? Oh, well, okay. Wait, why is it returning false? It worked up to these many things and it just stopped working. Do I need to pi delta by the way? Wait. Actually, I guess I did not. Well, because of the move 1. Because it always does anyway. Is this work the other way? No. So it's not quite what I want yet. No, because the move 1 applies that already. So it does seem order dependent for some reason. Oh, because why is this? Ugh. Move 1. That means that pi delta 1 may not be right. But it does seem to check out for all small things up to like a lot. What is this? So it works up to like 2 to the 10, which is 1,000, and then it just stopped working. Why? Okay, so this is the simulated one. So the simulated one has definitely way more stuff. But why? I thought I was close because I was being able to replicate it, and then actually this was by accident, but I didn't mean to test that high, and then but now it sees that it's no bueno. Why not? How? Why does it, how does it just stop working all of a sudden after 1,000 moves? Is there some weird thing? It's up by a lot. A lot of flips, at least. How does it work for all the other previous ones? And then like just let's get rid of this for now. Oh. Wait, what? Maybe there was some cheating here due to move is equal to 1. Oh no, this is kind of intentional. But apply delta of 1, it may be weird. Though it works for all the other ones up to like 15, 10 or something, 11. Why? How? How does it match everything up to? Is there some like weird memory things or? That's wow. Did not expect that, honestly. That's not great. Did I put out the wrong thing? Oh, why would I put out? Oh, does it have like a print function or something? Code print delta. This is old print delta. I guess print delta is the same as calc delta, so what am I printing? What do I want to print? Just print cons, I think, right? Well, I honestly did not expect. What am I saying? I didn't expect this to happen. Well, I mean, I was like, you know. Like, if it worked, why would it stop working after 11? And these two states are different because there's an NR different. And the BX. Well, the states are definitely different. We have to look, maybe earlier they're different. And I just didn't know. What does deep copy even do? Oh yeah. Let's look at this one first now. Are they the same? I guess so, right? So then what happened to... These two are the same because the delta strings are the same. But why does... What changes at 9? These are way different. That px. Are there any other states that could be changing? Like FDPX should be different, and it should be here somewhere. Yeah, it's here. Why is it not here? Let's say we move one less move. Would everything still be the same? No, everything's kind of messed up. Even from the first shot. So maybe that's a bad example, but that's just... PX is already different. FTPX. Is that one of the zero cycle ones? Is that right? Yeah, I have to add a thing to it. FTPX. FTPX is 0 for a lot of... no, I mean it's here somewhere. So we definitely think it... What does this print means? That means my assumptions maybe just wrong. Maybe that tell me how. Well, subtracting by 1, moving one less move is really bad. It's already not true for even very basic cases. So these are the changes for every 2. Should be right. I mean, it's right enough. Oh, this may be wrong just because now we're calculating, or we're moving the previous ones incorrectly. Okay, fine. All right. I'm just being really silly, but still, how does this move after 10? Why? I guess we'll just have to, you know, calculate it. Okay, right. So then now, okay. It's just 10,000, well, 1,000, so. It's returning false for, oh, maybe not 0. Let's just say 10. Did I print before? Oh. No, I print some stuff before the sort force. I should anyway. That's weird. So at 10, even 10 steps, I'm just doing really funky things. So this, oh, whoops. Which one do I do first? So I do the math first, and then the actual calculation has more. How did it work so well on the other one? And just by luck? Like, how can you be lucky for 10 test cases? Or like, that's crazy. Crazy. Just make it slightly faster. But it seems to be not even working for 10. Let's say we want to move, I don't know, 3. It's not even waiting for 4. I don't get it. I don't get it. Am I? Seems like I should be right. Okay, well, 4 is what it changes for 4. Okay. Do I have to do a pi delta to 0 first? Okay. That fixed things for some stuff. So let's see if I can fix this for. No, it still doesn't work on numbers like after 10 for some reason. I mean, there's some reason maybe just that my initial thing may be wrong. My initial assumption. So it feels somewhere between 1,000 and 2,000, right? It feels at 2 to the 11, which maybe is 4,000. I don't know if I'm off by 1 on that, but still, we'll find out pretty soon, I guess. Like everything is matching perfectly so far, up until 2 to the 11. That is actually surprising, but okay, fine. Let's just do 5,000. Well, we already tested. There we go. This may take a while, but just double check real quick. 496 is 2 to 11, so okay. So 4,000 is already wrong. Why? Why is that? Is there a number in between? This could be binary searched, but I am lazy and there's only a few thousand. Maybe I should still binary search because it seems like it's taking a while. That's wild. Like, what changes at that state? Also, actually, a binary search clearly. This is a fraction of a time in binary search. But I really didn't. And it's not like the answer is in there and that's why it is broken. Otherwise, we would have found it already. And also, what I'm doing is n squared, which is why this is so slow. We could have done this much faster. We just kind of, yeah. But we didn't have a state machine thing. Like maybe we have a state thing, then we can do it in an easier way. Like we have an object wrapping the machine. But the way that I wrote it is just I have essentially a global for the machine, and then like so I can't really reuse it in two places easily. I did not expect this to go on for this long, to be honest. I thought we'd just find a number and then I could debug it. Oh no, I forgot my Duolingo yesterday. Oh well. Alright, fails at 3800. Why? Like 3797 or whatever it is. How do we control this out? Because this is the number fails. Why is that? Is it the flips? 3797. So this is from my application. Why is that? Is there something that cycles not power of 2? Maybe that's why? No, that doesn't make sense. How can that even be? I mean, I guess it could be. I think I just made an assumption. Due to cycle length should be power of 2. Is that not right? And delta means that I'm actually doing more stuff. So I'm doing more. I'm applying things that are not part of the cycle, like these switches. A lot of things change here than theory. Why? How? Well, the theory may be just that this 2 to the 1,000 was 3797. But, well, I mean, maybe just be that this is wrong, but this is constructed wrong. Is why. But why? How? Oh, I guess 11 is the wrong one, but so 11 is the wrong one, but why? That is. What would I have? That one's. What do I print anyway? I print the deep copies. So for 11, So I don't know how this works. How would... There's some funky things going on here. I think I'm just wrong on some of these things. Oh, wait, no, I'm looking at the simulation, so simulation is fine. What I want to do is cycles. Have they put it up? Oh, it's right here. Oops. So 11 thinks that, or 10 thinks that this is the these are the cycles. The length 10. Oh man. So 2 to the 11 is wrong, so that's probably why the 3000 whatever is wrong. But why? I don't get it. How can this be wrong for partially? Where could it have gone? Where does FTPX gone? What are the states? Two 11s brought up two of the 10s. This. Okay, what does 11 mean? So when I is 11, we're calculating. So 2 to the I, so then we do 2 to the I prime, so that means for 211 we do. So that means that like it's wrong a few steps or 2 steps behind, because now it's calculating I. Well, it's calculating I plus 1 to get the changes, right? So if I plus 1 is wrong, that means the 12 is wrong in this case. So calculating 2 to the 12 is wrong. But why? And I guess this is maybe the first number that used. No, that's not even true. Don't know why 3796, but maybe that doesn't even matter. So this is consistent with what should happen, which is good, I guess. But it still doesn't help me to debug. Do I have a bug? Or and why would a bug only pop up after this much? Or is it just a misunderstanding of the problem? Like, can a thing flip on for the first time? Maybe I could simulate that. Okay, maybe I was just wrong on my assumption. Okay, let's see. Press. Presses. I thought it was presses, but apparently you can't find it. Oh, you're right. It's not presses per se. Well, I guess this probably just never got to, that's why. Okay. Even show up. Stop the presses. I was really wrong. I thought that are these right? I thought that these things only changes the power of 2, but apparently not, so maybe that's why. So let me see. That's actually, let's run the first 4,000 before we even do anything. So. I mean, apparently it does more in the future, but I think that's just weirdness. I don't know, I mean, oops. Okay, so this is why. Apparently some things do change. I was wrong. I thought that everything would be powers of 2, but apparently there's some power ones. What's KC again? I feel like KC was important. KC. KC gets sent, or yeah, things get sent to KC. And what is the RX? Oh, and then KC. So pH 2, 3, 4. 1, 2, 3, 4. So only 4 things get sent to KC, and they all get sent a 1 at some point. Let's see. Where's my I don't even know where my things are first. That's what I call it. Okay, and then also if name is equal to KC, print presses sender name. I want to know if it turns it off. So it turns it off and turns it on, and then turns it on again. It's only so this is a multiple of this, so that's good. So then it's just a multiple of these 4 numbers maybe, or at least LCM. Let's do a calculator on Google's, or maybe just copy and paste. Maybe I should have done that to begin with. Why do I still have to see stuff? Did I take it out? Huh? Am I running the right code? Okay, so just these 4 numbers. Where did I put my stuff? Say what? Say what? That's why it felt weird. Why would I put it here? It's just such a random place to put it. But okay, fine. I mean, I don't know. I guess I should have done it that way. I mean, this is just super specific for the examples, though. But I guess I should have. I guess I just didn't expect it in this way. But I mean, if I got it, but there's a really that was an effort for sure. I think this. I'm trying to think how to summarize this. Yeah, let me put it first for a second. Are these always the same? I guess so. I didn't really think of it that way. Are there more? It's 100,000 for fun. We don't need this anymore. We don't even need this anymore. I definitely go the crazy man's thing, but I really thought it was a different problem in a way. I guess nothing comes before. I don't. This was a hard one. I mean, I don't know. It just. It's one of those things for sure. When you see the answer, you're like, well, it's not that bad. But I think I just went the wrong way with how I thought about this. One is that I didn't. Yeah, I mean, I definitely went about it the wrong way. I thought I could do like a, because what I was doing was that I was thinking that maybe I could, after building out the components, I could do binary search, and which I guess maybe it wouldn't even make sense, because you'll always have it wrong, and the reason why that's wrong is because you well, my assumption was that changes only happen on the powers of 2, so that was already kind of that was correct except for these things. I think maybe we looked at it a little bit thing we could. Because you can think about all these other numbers as yeah, because pH, because even if I did this manually, it would have been faster if I did it like this, but I didn't even, because pH is just, what is pH? Oh, because pH is an inverter, not a con thing. That's why it doesn't get print. I don't know. To be honest, I don't know if there's any reason why this would work. Or like I don't have any mathematical proof for these ideas in general. Just kind of stumbled on the answer on debugging why something failed after a certain amount, and the reason is because there's a cycle length that is 3,797, and then after that, I mean, I recognize KC because we looked at the input. We looked at the input, and then I was like, oh, wait, this is one of the last things that goes out to the RX. And so I just looked at when they print out these things, and then assumed that they were cycles, which I had no business of knowing. I think we just kind of did add an if statement for yeah, I just had here to kind of verify it. I mean, it's not really verification, it's just like, oh, look, this and this is this times 2, and then 5 further down it's just another. So then you see the cycle, but then it's not clear to me you know, that I could have proven this. Of course, after you see the cycles and you're like, oh, there are 4 things, and then all right, let's see if this works, and then it works. I don't know. I should have done part 1 faster though. That was a mess. Oh well. Part 1 was just simulation. I don't think there's anything hard about that part per se. I mean, there's some processing and some minor tricky edge cases, but if you get all your edge cases right, there's nothing to understand per se. Part 2, I don't know what to make of it still. Like, could I have done this smarter? Or like, could I have arrived at the answer quicker? I don't know that, you know, I don't know that what we end up with a fair assumption. I mean, we end up discovering it, but like, for example, one of these numbers could have been, you know, like 100,000, and you would never know, right? Or like it would take forever to calculate or whatever. I don't know if I could have done this in a smarter way. Anyway, that's all I have for this one. I think I don't have any comments about part 2. Well, nothing to really learn, so my apologies for that. Because I think a lot of it is just guessing certain things, and I don't know that I would have gotten it. I mean, maybe on some days if I get lucky and I guessed it correctly, maybe. Like, you know, some days I'm just, you know, feeling better about it. But even those days, right, like, can I explain that? I don't know. So I don't know. Yeah, so I don't have much to add for this one. So we just kind of got the ends up by discovering these properties, but these are not properties that you can kind of like look at the problem and observe, I think. I don't know that you can assume certain things are cycles, though it seems like all the conjunction stuff is cycles, and the flip-flops are kind of, I wonder if flip-flops have cycles, but the conjunctions are on cycles, but so you could brute force the ones, but I don't know that that's it. Like I think that's such a leap in intuition, or just like problem solving. I mean, you know, the smart people still solve it, so it's just me. But I'm trying to think. Like, I think what I'm trying to do in for retrospective, which is kind of what I'm doing now, is just like, could I have done things better? And I don't know that I can without just luck. I mean, maybe some of it is AOC specific experience that I've been kind of not practiced on. Like maybe I could have been like, oh, let's be hyper specific about our inputs, which is a thing for AOC, but I definitely did not do that. Yeah, that's what I have for this one. Let me know what you think. If you're watching here now, thanks for watching. Definitely appreciate it. Let me know what you think about this one. Let me know how you did this one because I'm curious in general because I'm also trying to learn. So, yeah, stay good, stay healthy, to good mental health. I hope my mental health is good after this farm. I'll see you later. Take care. Bye bye.